Assalamu alaikum wa rahmatullahi wa barakatuh. Welcome to another computer science lecture for 9618A2. This is the last chapter for paper number 3, Advanced Theory. This is chapter number 20, Further Programming. Today we are going to discuss 20.1, Programming Paradigms. A programming paradigm is basically a fundamental style in which you can write your code in a programming language. Paradigms are characterized by concept and abstractions they utilize to represent programming elements such as how you use functions, how you use variables and constraints. These all make up a programming paradigm. They also define the nature of computational processes such as assessment, assignment, evaluation, data flow, etc. There are several programming paradigms and each one has its own advantages and disadvantages or their own unique approach. This include the ones in our syllabus basically include imperative paradigm, object oriented or OOP paradigm, functional paradigm, logical, declarative, etc. So first of all, the thing in our syllabus is the low level paradigm or low level programming. It is basically the concept of programming something in a low level language, especially in assembly language, about which you kind of have studied a little bit in chapter number 4 as well. These low level languages allow the direct manipulation of registers and execution of binary instructions according to your processor's architecture. Due to their proximity to the hardware, these languages have very excellent control over the hardware and over system resources. This is particularly advantageous in systems with limited resources or newly developed hardware. This results in very highly efficient code and fast executing code. It is critical for applications where response time and speed are of the topmost priority. In low-level languages, if you want to program, then it requires a very comprehensive knowledge and understanding of the computer's internal architecture, because you will have to manage details like memory addresses, registers, processing algorithms, etc. Code written in low-level language is often specific to a particular type of processor or system, and it cannot just run on any hardware. Applications of low-level programming for system software development, like for operating systems, for performance-critical applications, for embedded systems and IoT devices. IoT stands for Internet of Things, where you can use your cell phone or a central device to control basically everything in your home, such as Alexa, etc. Embedded systems, and then we have for hardware interfacing applications that involve direct interaction with the hardware. We have several addressing mods in low-level programming. Don't worry, this part you have already studied in chapter number 4 as well. This would be sort of a playback to the things you already learned in chapter number 4. So we have immediate addressing, where the operand is the immediate address, like move a hashtag 55 would place this value 55 in memory location A or into the accumulator A. Then we have direct addressing, where the address is stated in the instruction. For example, move a 1200H. Now this would mean you go to the memory location 1200H, you get the contents from over there and you load them into the accumulator A. This is commonly used for accessing variables stored in memory locations. Then we have indirect addressing. The memory address of the operand is held in a register, like move a @R1. Now first of all, you'll go to R1. Over there you'll get the another address. You'll go to that address, and from there you'll fetch the contents and load them into accumulator. Then we have the indexed addressing, combines a base address held in a register with an offset to calculate the actual address. For example, move a BR1, it would calculate the address where you need to go by adding the contents of R1 to register B, and then it will go to that address and fetch the contents from over there. This is used for iteration or for arrays and for specific data structures. Then we have relative addressing, where the operand's address is calculated relative to the position of current instruction in memory. This is used for control flow instructions, like JMP 8 would make the program jump back to memory address 8, or it would make it jump back 8 bytes from the current instruction to implement a loop. Next, we have imperative or procedural programming paradigm. Basically, all the pseudocodes that you have written so far, they kind of fall under this category, where you make procedures and functions and you incorporate them into your code. That is kind of known as procedural programming. An imperative program tells the computer how to get a desired result, in contrast to a declarative programming, where a program describes what the desired result should be. There are many imperative programming languages such as Pascal, C, C++, BASIC, etc. Now, procedural programming languages often use a structured approach, that is sometimes known as structured programming as well, where you incorporate a lot of functions and procedures and the use of local and global variable in order to get something done. Programs written using imperative paradigm may be smaller and they may take less time to execute than programs written using the object-oriented or the declarative paradigm. This is because there are fewer instructions and less data storage is required for the compiled program. Imperative programming works well for small, simple programs. Programs written using this methodology can be easier for others to read and understand. Alright, let's move on. Then we have object-oriented paradigm. This is simply known as OOP as well. Object-oriented programming revolutionizes the object programming methodology by shifting focus to objects and their interactions with each other. This approach is instrumental in handling complex software development projects, making the code more flexible, modular, and user-friendly. OOP basically works on 4 principles: the encapsulation, inheritance, abstraction, and polymorphism. First of all, let's discuss what are objects and classes. These are the fundamental building blocks of an object-oriented paradigm. Objects are instances of classes, whereas classes are the building blocks of an OOP program. Objects encapsulate data in form of fields known as properties or attributes, and code in the form of methods or functions. Classes are the blueprint for creating an object. So basically, if you have to do something in OOP, first of all you create a class for it, then you use that class as a sample in order to create an object or a method for executing a piece of code. Classes define the structure and behavior or the methods that the objects will have. Each class in OOP serves a specific purpose and defines the scope and functionalities of its object. OOP has 4 primary principles that we have already discussed: encapsulation, inheritance, abstraction, and polymorphism. This is an example of a class written in Java, public class vehicle. So this basically tells the computer to make a class that can be accessed by anyone, and the name for that would be vehicle. Then make a private object by the name of speed, public vehicle. Now this is a public method or function that anybody can use, which says speed is 0. One thing that we use in our paper as well is known as class diagram. It is used for describing structure and behavior of a class. It provides a visual conceptual model of the system in terms of classes and its distribution. Each class is represented by a rectangle, and it can have 3 components: a name, attribute, and operations. Modifiers are used to indicate visibility of attributes. It can be plus is used for public visibility, anyone can access it. Hashtag is used to denote protected visibility, only derived classes or friends can access it. Negative or dash sign hyphen is used to denote private visibility, nobody except for this class can use it. So here is the name of the class, account name, customer name and balance are protected object attributes, whereas add funds, withdraw and transfer are methods or behavior or operations which are all public. Inheritance is a mechanism where a new class, which is usually known as a child class, derives properties and methods from a parent class or from an existing class. Now inheritance can be represented by an inheritance diagram that looks something like this. This would be customer would be the parent class, regular customer and loyal customer can be the derived class or the child classes. This is usually how you would see it in your paper. If a class inherits from more than one classes, it can be drawn like this, because you can create a class that inherits from 2, 3 or 4 classes. A base class that is never used to create an object, it is known as an abstract class. For example, like this, library item is an abstract class because the book and CD subclasses are not using any of its methods or any of its attributes. Then we have polymorphism. Polymorphism allows objects of different classes to be treated as objects of a common superclass. It means having multiple forms. Polymorphism as a word means having multiple forms. In object-oriented programming, it typically manifests as methods having the same name but behaving differently based on the object calling them. So basically you can have functions with same name in multiple classes, but if you call them with the reference of one class, they'll do something else. If you call them with the reference of another class, they'll do something entirely different. This principle is crucial for simplifying code and improving its maintainability. Then we have encapsulation, which involves bundling the data and code together in a single unit or in a single class. This principle is a mean of preventing accidental interference and misuse of methods and data. Then we have abstraction, which means hiding the complex reality while only exposing necessary parts. This involves creating simple, user-friendly interfaces with hiding complex programming data from the user. Aggregation, containment. It is a special form of association that represents a relationship between objects. It is a method to combine simple objects or data types into one complex one. For example, in a library management system, a library class may have references to objects of a book class. The aggregate is the parent class. The components are the child class, like this. Exhaust system can have muffler and tailpipe. There can only be one muffler, whereas there can be up to 2 tailpipes. Getters and setters. Getters are methods that are used to retrieve or access or print, you can say, attributes or variables or objects, whatever you want to say. They are essential for reading private attributes. Setters are methods which are used to set or update or assign values to variables inside the class or objects inside the class. Implementing OOP involves designing classes, creating objects from these classes, then defining interactions between them. Class design involves defining a class with the specific attributes and methods. It includes constructors, which are special methods used to whenever you make a class. We always run a constructor operation or a constructor function or a constructor method in order to kind of make an object from that class. The process of creating object from classes is known as object instantiation. Each object created has its unique identity, its unique set of attributes and behavior. OOP aids in program solving by enabling developers to break down problem into smaller objects by leveraging inheritance, polymorphism, encapsulation, and abstraction to logically and intuitively structure solutions. Through inheritance and polymorphism, code can be adapted for new purpose, enhancing efficiency. Now, these are the advantages of object oriented programming: modularity, the source code can be written and maintained independently; reusability, these classes and objects can be reused again; scalability, it allows the creation of objects as needed. Then we have the declarative programming paradigm, the last thing in our syllabus. It is characterized by its high level approach to problem solving, where the emphasizes is on the outcome, as like it the emphasizes on what the outcome should be rather than how to achieve it. Unlike imperative languages, declarative programming does not involve control structures like loops or conditions. Declarative code tends to be shorter and more readable due to absence of intricate control flow details. Declarative programming uses statements of facts and rules together with a mechanism for setting goals in the form of a query. Now, in your paper 3, you would almost always get one question from this topic from declarative programming, almost always in every paper 3. Writing declarative program is very different to writing imperative programs. In imperative programming, the programmer writes a list of statements in the order they will be performed, whereas in declarative programming, the programmer can simply state the facts and rules in any order. For example, cat, Tom, this would mean that Tom is a cat; mouse, Jerry, this would indicate that Jerry is a mouse; animal X, colon dash cat X, that would mean each cat is a member of animals, or basically each cat is an animal. Similarly, each mouse is also an animal. Big cat, this would mean cats are big, and small mouse, this would mean mouse is small. So this is basically everything you need to know about declarative programming and overall about different programming paradigms. And after this, you should be able to solve questions from chapter 20.1 with a little bit of practice. You can go through. I'll see you guys in the next class. That will be our last lecture for paper 3, because in the next lecture we'll finish 20.2. that is the last topic in our syllabus. So I'll see you guys there. If you make sure to leave some comments below and do tell me whether you like the lecture or not. Give it a thumbs up, share it with your friends. I'll see you guys in the next lecture. Till then, take care. Allah Hafiz.